What's going on, everybody? This is the walkthrough for MCDS 2.4, 2.5. And basically on this one, we had a demo, and what we started off with in the demo is we used a digital thermometer and we heated up some water. And as the water was heating up, we saw the digital thermometer registered specific temperatures. So the difference between a digital thermometer and an analog thermometer is a digital thermometer will only register specific temperatures, and in between those temperatures, it really doesn't register. So that's why you have this kind of stair-step looking pattern on these temperatures. Because in one instance, it is a temperature, and the next instance, it is a different temperature. An analog thermometer, so the kind that you traditionally have, it kind of goes up and down with all the temperatures in between. And so it kind of like what I say, like rolls through all the numbers. Whereas an analog one, it only kind of clicks on specific temperatures. So in the graph, you have this stair step. So the main difference between an analog and a digital thermometer is the analog thermometer records all numbers and is continuous, whereas the digital only records specific numbers at any given time. So when you look at the page, we have a couple of simple questions that are in blue. And those questions are describing a digital signal. So a digital signal is right here, English and Spanish. What are binary numbers? And the next question is, what time does the clock say? It's right here. And when you're looking at a digital signal, basically what binary means is things are either a 0 or a 1. It's either off or it's on. And so based on these digital signals, you can easily transmit information. And it does become a little bit more elaborate when we get into some different encoding. But basically, a digital signal is in binary, and it's just based on two values, 0 and 1. So what are some different digital readouts that you encounter every day? This could be a digital clock on a stove, a digital clock on a microwave, maybe a digital readout on your phone of the weather. This could be a digital readout of information that might be on a billboard. And again, those are all just digital readouts based on zeros and ones. It's either one thing or another thing, on or off. In the next section, 2.5, we look at what happens when we have different binary formats. So if we look at this photo, we can see that it's a photo of some sort of animal, perhaps. And the main shape that we see are squares. So with each of these squares, they represent a single color. However, if we move the slider one direction to the right, we notice that those different squares, they become smaller and they become more defined with different colors. If we move it one more space to the right again, those squares then become even smaller. Focus on the dog's tongue. And this one, it's just basically 2, maybe 4 squares. In this one, you have a shape that's close to maybe 16. And now this one, you have a shape that's close to 64. And maybe this one might even be like 720 or 1080. So the resolution increases significantly. So what happens when we slide the photo from the right to the left? The photo becomes more clear and the squares become smaller. Each square has its own little unit of information. What do the terms megabyte, gigabyte, and terabyte stand for? They all stand for different size storage. And what can happen to a digital signal as noise is added to it? Well, here is a digital signal of 0 and 1. Here is noise. And although noise will interfere with the digital signal, we can still easily see that these are zeros and ones. So that is your quick review of MCDS 2.4 and 2.5. Make sure you get things turned in, get some credit, and improve that grade.